Lesson 10.9, simplifying single radicals. Basically, it's just an extension from yesterday's 10.8. Only difference today is that you're not going to probably be dealing with perfect squares. So you'll want to do the prime factorization inside of each of your square roots here. So I'm going to go ahead and start off with example 1, do our prime factorization in example 1. So I'd start out with 48 in my calculator. I know that 48 is divisible by 2. When I divide 48 by 2, I'm going to go ahead and throw a 2 in here because I've divided by 2. I'm left with 24. I can divide by another 2. I'm left with 12. From 12, I can go ahead and divide by another 2. Then I'm left with 6. And 6 can break down into a 2 and a 3. So the only thing I have left here is my r, and I have 1 r. So this is dealing with square root. Remember, in a square root, you need 2 in order to move it out. So here's a set or a pair of 2's. Here's a set or a pair of 2's. So what I can move out in this problem are 2 2's. Inside your square root, you still have 3 times r, which is 3r. 2 times 2 giving us 4 root 3r. And here is our problem simplified down to that single radical that we have. Same in example 2. Again, prime factorization. I'm going to go ahead and use prime factorization here. And 343 is divisible by 7. So when I divide 343 by 7, I get 49. And into 49 can break up into 2 7's. So basically 7 cubed gives us 343. And then I have n cubed, which is basically 3 n's. And again, looking at this problem here, I'm dealing with a square root. So square root, I need 2 or a pair in order to move something out. I can move out a set of 7's, and I can move out a set of n's. So on the outside I have 7n. Inside your square root, you still have a 7 and an n, so we have 7n. So our answer here for example 2 is 7n square root 7n. Example 3, 600xy. Again, start off by prime factorizing here. So we have our prime factorization. We know a 2 can go into 600, so I'm going to divide it by 2. Brings me down to 300, which another 2 can go into, so I'll divide that by 2, giving me 150. When I divide 150 by 2, I get 75. In 75, I know 75 is divisible by 3. And I'm left with 25, so it gives me 2 5's here that it can break down to. And then our variables, we have 1x and 1y. Again, dealing with square root. Square root needs a pair in order to move out. So I look at my problem here under my radical. I can move out a 2, and I can move out a 5. So I have 2 times 5. Inside my square root, I still have 2 times 3 times x times y, and I get 10 root 6xy. Example 4, I'm going to have you go ahead and try to work it out here. Again, you want to go ahead and prime factorize, and we know that 448 there, it's divisible by 2, so you can start off with a 2 in that radical. So list off all of your prime factorization and see where we wind up with, and we'll check back in. Under my radical or under my root, numerically, this is what I'd have. I'd have 6 2's and a 7, along with 4 m's, and we'd have 1 n. Square root, go ahead and combine some pairs here. So it looks like I can move a 2 to the outside, another 2 to the outside, another set of 2's, and m's. I can move out one set of m's and a second set of m's. So I'd have m and m. Inside the radical, or inside your square root, we have a 7 left over and an n left over. And we would wind up, when multiplying things out here, 2 times 2 times 2 gives us 8 m to the second power root 7n. This will conclude our lesson on 10.9.